Day 755 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3093, longest common suffix queries. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two arrays of strings, word container and words query. For each word query of I, you need to find a string from words container that has the longest common suffix with words queries of I. If there are two or more strings in word container that share the longest common suffix, find the string that is the smallest in length. If there are two or more such strings that have the same smallest length, find the one that occurred early in words container. Return an array of integers ands, where ands of I is the index of the string in words container that has the longest common suffix with words query of I. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have our input words container equals a string or equals an array of strings. First string ABCD, next string BCD, and the last string is XBCD. And then words query equals an array of strings CD, BCD, and XYZ. The output is an array of integers 1, 1, and 1. So let's break this down one step further by taking a look at the explanation. So explanation says we're going to look at each queries of I separately. So for words of query equals 0, or excuse me, for words of query 0 equals the string CD, right? So that's this right here. So strings from words container that share the longest common suffix CD are indices 0, 1, and 2. Among these, the answer is starting at index 1 because the answer is string at index 1 because it has the shortest length of 3. So in this case, with right here, words query CD, we want to see how many strings up here have the suffix CD. So as you can see, every string up here has the suffix CD, right? So it says up here, if there are two or more strings in word container that share the longest common suffix, find the string that has the smallest length. So since all of these strings have the common suffix, we're going to go with the one that has the smallest length, which is this one at BCD at index 1. So we'll put a 1 right here for query 1. So now we're on to query 2. Query 2 is BCD. It says for words query 1, which equals BCD, strings from word container that share the longest common suffix BCD are at indices 0, 1, and 2. Among these, the answer is the string at index 1 because it has the shortest length of 3. So once again, we have BCD. All of these strings have the suffix BCD. Right there, we have it right there, and we have it right there. Once again, since this one is the shortest in length of length 3, and these both have length 4, we're going to return index 1 because it has the smallest length. So we put a 1 right here for this query at index 1. Boom. So now we're going to do this query right here, XYZ. It says for queries of 2, which equals XYZ, there is no string from words container that shares a common suffix. Hence, the longest common suffix is a blank string that is shared with that is shared with strings at index 0, 1, and 2. Among these, the answer is the string at index 1 because it has the shortest length. So in this case, for this query, we have the string XYZ. None of these strings in word container contain XYZ, so the longest common prefix with this would just be a blank string because none of these strings in word container have XYZ. So since it's a blank string, all of these can fall into that category of the sharing the common suffix. So then we're going to return this one because it's the smallest. Boom. So now we're going to take a look at example 2. So in example 2, we have our input words container equals a string or an array of strings A, B, C, D, E, F, G, H, then P, O, I, U, Y, G, H, then G, H, G, H, G, H, Words of queries equals array of strings GH, ACBFGH, and ACBFEGH. This time output is an array of integers 202. So let's look at the explanation. Explanation said, let's look at each words of query I separately. So for words of query of 0, that's a string GH, right? So that's this right here. Boom. It says strings from words container that share the longest common suffix GH are indices 0, 1, and 2. Among these, the answer is a string at index 2 because it has the shortest length of 6. So once again, right, we're looking at this in GH and words query at index 0. All of these have the suffix GH. So since they all have the suffix GH, we're going to return the one with the smallest length, which is this one at index 2, which has a length of 6, right? Boom. Which has a length of 6. So we put a 2 right here for this query. Boom, now we're on this query, ACBFGH. It says for words query of 1, ACBFGH, the only string at index 0 shares the longest common suffix FGH. Hence, it is the answer even though the string at index 2 is shorter. So, right now, where we at? We're right here, right? So since index 2 is the only not index 2, index 0. Since index 0 is the only string that comes close or has a common suffix, right here, the common suffix is FGH, right? This has FGH as the suffix. This has FGH as the suffix. Nothing else has FGH as the suffix, so we can return index 0, right? Boom. So we put a 0 right here. Boom. So now let's take a look at this query. So for words of queries 2, the string ACBFEGH strings from word container that share the longest common suffix GH are at indices 0, 1, and 2. Among these, the answer is string at index 2 because it has the shorter length of 6. So once again, now we have this string right here, but the only common suffix would be this GH right here. Now, all of the strings have this common suffix, this GH, but we're going to return this string because it's the shortest because it has a count of 6, where this has a count of 7 and this has a count of 1, 2, 3, 4, 5, 6, 7, 8. Boom. So since this is the shortest, we're going to put a 2 right here in our output for this query. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, the first thing we're going to do is we're going to create a class of try nodes, which will be used to store the suffix character. So we'll come right here. We'll say class try node, open up the brackets, and we're going to store the child nodes for each character. So we'll declare a variable called children, and we'll set that equal to a dictionary. Sorry, y'all. The key is going to be a character, colon, try node. Boom. Come outside of that. Put the parentheses. Boom. Now we need to store the best index for this suffix. And the best means the shortest word length if tied in the smallest index. So we just create a variable for that to start, a default variable called best index. And we'll set that equal to -1. Boom. Now we need to track the shortest word length seen for this suffix path. So declare another variable called best length, and we'll set that equal to int.max just to start. Now we need to get the root of the try. So we'll come underneath this and we'll say let root equal try node. Put the parentheses. Boom. Now we're going to build a try using all words and words container. So we'll say for, open up the parentheses, index, comma, word. We'll come outside of that and we'll say in words container dot enumerated. So this enumerated is going to get us the index and the value of that index. So in this case, say we're looking at this array, and we got it. Say we enumerated this array right here, it will give us 0 and 1 for the value for this. Then it right here it give us 1 for index 1 and value 1, and then for right here it give us 2 for index 2, or it give us 2 1 for index 2 value 1. Boom. So then we'll open up the brackets, and first we're going to convert the word into an array of characters. So we'll say let chars equal an array, open up the parentheses, passing word. Now we're going to start traversal from the root. So we come underneath this, declare a variable called node, and we'll set that equal to root. Boom. Now we're going to insert characters in reverse order because we're matching suffixes. So we'll come underneath this, and we'll say for char in chars dot reverse, put the parentheses, we'll open up the brackets, and we're going to create a new try node if needed. So we'll say if node dot children, open up the square bracket char, we'll set that equals nil, we'll open up the brackets and we'll say node dot children, square bracket char, we'll set that equal to try node, put a parentheses, boom. Now we'll come underneath this and we're going to move to the child node. So we'll say node equals node.children, square bracket char, come outside of that, exclamation point, boom. Now we're going to update the best word information for this suffix. So we will prefer shorter words and smaller indices if lengths are equal. So we'll come underneath this and we'll say if chars dot count is less than node dot best length, or 2 vertical lines for or, open up the parentheses, char dot count equals node dot best length, and 2 and signs, index is less than node dot best index. Come outside those parentheses, open up the brackets. Hold on, let me just clean this up for y'all. Boom. Open up the brackets, or hold on, do it like this. Boom. We'll open up the brackets and we'll say node dot best index equals index. Come underneath that, we'll say node dot best length. Sorry, y'all. Length equals chars dot count. Boom. Now we also need to update the root node, and this handles cases where no suffix matches. So we'll come underneath this and we'll say if chars dot count is less than root dot best length, or 2 vertical lines, open up the parentheses, chars dot count equals root dot best length, and 2 and signs, index is less than root dot best index. Sorry, y'all. Index. Come outside of that. Open up the brackets and we'll say root dot best index equals index, and we'll say root dot best length equals chars dot count. Boom. Now we need an array to store the answers for each query. So we're going to create our result array by coming right here, declare a variable called result, and that set that equal to an array of integers. Come outside of that, put parentheses. This is where we're going to store our output. Then we're going to process every query in words. So we're going to say for query in words query. We're going to open up the bracket and we're going to convert queries into characters by saying let chars equal, or excuse me, yeah, we're going to convert queries into characters by saying let chars equal, it's going to be an array, open up the parentheses, and pass in query. Boom. Now we're going to start traversal from the root. So we'll come underneath this, declare a variable called node, and we'll set that equal to root. Then we need a default answer is the root's best index, which will be used if no suffix match is found. So we'll declare a variable called best. We'll set that equal to root dot best index. Boom. Then we're going to traverse the trie using reverse characters to match the longest possible suffix. So we'll come underneath this and say for char and chars dot reversed, put the parentheses, open up the brackets, and we're going to stop if the suffix path does not exist. So we're going to say guard let next equal node dot children square bracket char. Come outside of that, we'll say else, open up the brackets, and we will break. Then we'll move deeper into the trie by coming underneath this. We'll say node equals next. Then we'll let me see. We need to update that best answer with the current suffix match. So we're going to come underneath this and we're going to say best equals node dot best index. Then we need to store the best matching index for this query. So we'll come underneath this for loop and we'll say result dot append, open up the parentheses, pass in best. Then we need to return all query results by coming right here. We just say return result, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly. Okay, we got a compile error for the value. Reverse. Maybe that should fix it. My bad, my spelling was off. Okay. Char.count. Okay. Just a moment, y'all. Let me see. There's no member dot count. So this should be charged with an S. Now let's give it a run. See if that fixed it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 870 milliseconds beats -% of users. That's what I'm talking about. We'll take that. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. This is the bottom of the code, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.